Question number 8. In question number 8, they have given us a rational function and they're asking us to express it in partial fraction, and then B part we have to carry out this definite integral. Let's talk about the part A first. X squared plus 9x over 3x minus 1 x squared plus 3. This is our rational function. Let's assume that it is equal to a over 3x minus 1. Before we do this one, you should always ensure that the degree of numerator, which is 2 in this case, is less than degree of denominator, which is 3 in this case. This is 1 and this is 2, total 3. So we are good to go. Bx plus c and x squared plus 3 here. So now let's find the LCM of this one, which will be 3x minus 1 and x squared plus 3. And to merge these two, x squared plus 3 will multiply with the other numerator, which is xa, and bx plus c, the numerator of the second one, will multiply with 3x minus 1. Now, both of them have same denominator, we can ignore. Especially, what do we get here? X squared plus 9x, which was this numerator, equal to the numerator here, which is ax squared plus 3 plus bx plus c, 3x minus 1. Now, to solve this, our endeavor should be that one of the brackets becomes 0, and this can be made 0 if we let x equal to 1 over 3. So 3 times 1 over 3 will be 1, and 1 minus 1 is 0. This whole thing is useless with x equal to 1 over 3. So let's write here 1 over 3 square plus 9 times 1 over 3 equal to a 1 over 3 square plus 3. 1 over 3 square is 1 over 9, and this 3 and this 9 cancel, we'll have plus 3 equal to a here also 1 over 9 plus 3. So can we divide it by 1 over 9 plus 3 so that both of them get cancelled out? This cancels, this cancels. That leaves a equal to 1, not 0, 1. When something is cancelled by dividing or multiplying, we write 1. Okay, what about b and c? Let's compare now. There's no other chance. This x squared plus 3 cannot be 0, so we can't make anything else 0. So let's compare constants. So constant on the left side is nothing. Both of them are x, so there is nothing on the left side, 0. Here a times 3 will be a constant, so we'll write 3a. Here c times minus 1 will be a constant, so minus c. That's it. A is known to us, which is 1. So 0 equal to 3 times 1 minus c. Let's bring c to the left side. C equal to 3. Now to find b, we can compare coefficients of x square or x. I'm comparing coefficients of x square. Alright. So on left side, what is coefficient of x square? 1. On right side, a x square, this will be 1. I'm not writing x square on both, okay? Bx times 3x will also give us x square. So bx times 3x will be 3b x square. Again, no x square because I am comparing coefficients only. So 1 equal to a, this is a is 1 plus 3b. Let's bring this 1 to the left side. 1 minus 1 equal to 3b. 0 equal to 3b, that is b is also 0. Alright, so finally our partial fraction becomes a over 3x minus 1, right? So a is 1, that becomes 1 over 3x minus 1. B is 0, so we will not write it, we will just write c, and c was 3. Positive, yes, x square plus 3. That is our partial fraction. Now, in second part, they were saying, hence, find the integration of this function from 1 to 3 and simplified exact form. Okay. So let's try to do this. All right. So we have to integrate from 1 to 3, 3x minus 1 dx plus, let's keep 3 outside, 1 to 3, 1 over x square plus 3 dx. This is the second part, okay, b part. All right, so the integration of this is simple. It will be natural log of, let's put a absolute sign here, 3x minus 1. Okay, and what about this one? Plus 3. Now it is in the format of 1 over a perfect square time plus square root 3 square, a perfect square plus a perfect square. Whenever it is not there, though it is not a perfect square, I've just made it up. So its integration in straightforward way will be 1, rather this 3 already, right? So 3 over square root 3, because of this, tan inverse x over square root 3. This is what we have learned in our classes. If you don't understand how I got this, let me do it here hurriedly. Our integration was 1 over x square plus 3, right? So what we do, let's assume x equal to square root 3 tan theta. So dx over d theta will be square root 3 uh, secant square theta, correct? So dx equal to square root 3 secant square theta d theta, and we can square this also. X square equal to square of this, which is 3, square of this, which is tan square theta. So now we'll substitute, it was dx also here. Let's substitute everything here. So 1 over x square, 3 tan square, 3 tan square theta plus 3, and dx is square root 3 secant square theta d theta. All right. So now it becomes 3 can be taken common from these two, so it becomes 1 over, let's write 3, square root 3 also here. This is square root 3. I'm writing outside. The 3 I took from these two, I'm writing outside, so we're left with tan square theta plus 1. And on top we have secant square theta d theta left. Tan square theta plus 1 is exactly equal to secant square theta, so they cancel out. This will also cancel out. So we will be left with 1 over square root 3 d theta. That's it. And what is d theta? Integration of d theta? Theta plus c. And what is theta? From this particular assumption, theta will be tan square x over square root 3. So that's why I got square root 3 here. This was 1, right? So this is our integration from 1 to 3, and let me substitute the values 3 and 1 into this now. Okay. First of all, let's cancel out this one and this one. This becomes square root 3 when cancels out of this. So we are left with len 3 times 3, 9 minus 1, 8. So there is no need to write absolute anymore because it's positive. Plus square root 3 tan inverse x over square root 3, 3 over square root 3 plus c minus, we have to substitute 1 now, len 3 times 1 is 3 minus 1, which is 2. Okay, plus square root 3 tan inverse 1 over square root 3 plus c. C is cancelled first. Now let's open len 8 plus square root 3, 3 over tan inverse 3 over square root 3 is square root 3, so pi by 3. Now minus len 2 then minus, because of this minus, this will also become minus square root 3. Tan inverse 1 over square root 3 is pi by 6. So this ln and this ln can be made 1 ln 8 divided by 2. Yeah, because they are subtracting. And I'm not going to cancel this out because otherwise the denominator will become a square root, which is not allowed. So let's multiply this by 2 so that we get a 6, right? Plus 6. So to make this 6, I have to multiply this by 2 square root 3 pi. We have to multiply 2 here. I'm doing it all this mentally. Please, you can try your calculator if you're not sure how I'm doing this. This is what I got. So 8 over 2 ln 4. This is the final answer I'm seeing here. 2 square root 3 pi and square root 3 pi. Square root 3 pi is left by 6. And that's it. This is the final answer. Question number 9 is a vector question. In this question, they have given two lines L and M. This is L, this is M, respectively, and they have A and B constants in them. Okay, greatest, given that the L and M are intersecting, they intersect. Okay, they intersect like this. Show that 2b minus a is equal to 4. Okay, so let's assume that the point of intersection is x, y, and z. So let's convert the two vector equations given into parametric equation, and since this point, let's call it M. This point is common between the two lines. Their x, y, z coordinates will be same at this point. So what about the first one? Minus 1. Then we have 2 lambda, right? 2 and lambda plus 2 lambda will be equal to, from the second line, 5 plus a mu. All right. Similarly, the y coordinate will be 3 minus lambda, which will be equal to 4 plus b mu from the second line, and z will be 4 minus lambda equal to 3 plus mu. Since z coordinate does not have any a or b, so let's isolate mu in this one. So let's keep mu here and bring 3 to the left side. It becomes 4 minus lambda minus 3. So mu is basically 1 minus lambda. Now, since we've got the relationship between mu and lambda, let's substitute this relationship into the other part. Okay, so let's choose x1 first, this one. So minus 1 plus 2 lambda, which was on this side, equal to 5 plus a, and now mu has a value 1 minus lambda. So what does let's continue to take a on one side. Let's isolate this one. So 5 will go first. So minus 1 minus 5 plus 2 lambda equal to a1 minus lambda, and divide both sides by 1 minus lambda. What is left here? Minus 6 plus 2 lambda over 1 minus lambda equal to a. We got a in terms of lambda. Similarly, we'll get b also from the second set of equation. 3 minus lambda equal to 4 plus b, and mu is 1 minus lambda. Just like the previous one, we isolated a, we will isolate b in this case. So 4 goes to the left side first, and we are left with this b, and divide by 1 minus lambda, divide by 1 minus lambda. So b comes out to be 3 minus 4 minus 1. Minus 1 minus lambda over 1 minus lambda. Please never cancel this out. They are totally different. Here minus 1 has minus, here 1 does not have minus. So this is b. Now we have to show that 2b minus a equal to 4. So 2 and b is this, minus 1 minus lambda over 1 minus lambda, rather not equal to, minus a. A is this, minus 6 plus 2 lambda over 1 minus lambda and equal to 4. This is what we have to show. So since both of them have same denominator, we can write this denominator as 1 and multiply the 2 with only numerator. That's what we do, like this. If I multiply 2 times 3/5, we don't multiply 2 with 5, only with 3. So it will be 6/5, right? Similarly here, 2 times minus 1 will be minus 2 lambda plus 6 minus 2 lambda. So it has to be equal to 4. Okay, let me not write the right side. It will bias me. So minus 2 plus 6 is 4 minus 4 lambda equal over 1 minus lambda. Let's take 4 common out of this. 4, 1 minus lambda over 1 minus lambda, and voila, we got it, what we wanted. Just left with 4, which we wanted. We have shown this. Let's see what is the B part. And here is the B part. Given also L and M are perpendicular, so they not only are intersecting, they are 90 degree to each other. All right, this is the new thing, and we just assume that this was X, Y, and Z. All right, so find the values of A and B. When two lines are perpendicular to each other, two vectors are perpendicular to each other, their dot product is 0. Dot product of vectors. So in this vector equation, this part which is after lambda and this is after mu, these are the vector parts of the vector equation. So let me write that dot product equal to 0. So they are 2i minus j minus k dot ai plus bj plus k equal to 0. So in dot product we just multiply the coefficients of I, j and k. So 2 times a is 2a, minus 1 times b is minus b, minus 1 times 1 is minus 1 equal to 0. This is our equation. Now already we had one equation which we proved earlier, which was 2b minus a, this one, 2b minus a equal to 4. So we will write here 2b minus a, so plus equal to 4, so minus 4. I just rearrange the question, this equation, okay? I wrote it like this so that I can cancel out something. Nope. So let's do this a, I'll bring it to the right side. So 2b minus 4 is equal to a. That's what we can write. And substitute that in the first equation. 2 times a is now 2b minus 4. I'm using substitution. Minus b minus 1 equal to 0. 4b minus 8 minus b minus 1 equal to 0. 4b minus b is 3b. Minus 8 minus 1 is minus 9 equal to 0. 3b is 9. Divide both sides by 3. So we get b equal to 3. And to find a, we can use this one. A is 2b minus 4. 2 times 3 is 6 minus 4 is 2. So we got a equal to 2. What is the next part? C. When a and b have these values, okay, the values were a is 2, b is 3. Find the position vector of intersection of L and M. Position vector. And position vector is another format of coordinates. So let me use one of the coordinates I assumed in the initial first part of the question. These were the equations, and now we need to find the value of lambda and mu. Let's go to the first equation, which is this. So minus 1 plus 2 lambda equal to 5 plus a is 2. 5 plus 2 mu, right? So can we get one equation out of this? Yes. 2 lambda minus 2 mu equal to 5 plus 1. 2 lambda minus 2 mu equal to 6. Can I divide all of them by 2 so that it becomes a simpler equation? It becomes lambda minus u equal to 3. So lambda equal to u plus 3. Right? Now, let's use this second equation to get rid of lambda. So 3 minus lambda was equal to 4 plus b. b is 3 mu. Now, lambda is mu plus 3. So I will write 3 minus mu plus 3 equal to 4 plus 3 mu. So let's write here 3 minus mu minus 3 equal to 4 plus 3 mu. So 3 and 3 cancel out. Let's bring this 3 mu to the left side. Minus mu minus 3 mu equal to 4. Minus 4 mu equal to 4. So mu is minus 1 according to this. Then what is lambda? Lambda was mu plus 3. Lambda equal to minus 1 plus 3, which is equal to 2. So we got the values of lambda as well as mu. Let's confirm with z coordinate if it is correct. I'm 100% sure it will be right, but still let's confirm if our calculations are correct. 4 minus lambda is 2 equal to 3 plus mu, 3 plus minus 1. So 2 is equal to 2. See, we are perfectly correct. So, but the question was not to find lambda and mu. Question was to find the position vector of m. So let's use lambda, these equations to get the coordinates. X equal to minus 1 plus 2 lambda. Lambda is 2. So it becomes 4 minus 1, 3. Y equals to 3 minus lambda, which is 2, 1. What about Z? 4 minus lambda, 2. So 3, 1, 2 are the coordinates of M. Let me show you which one. Here. 3, 1, 2. So 3, 1, 2 are converted to position vectors. So position vector of M, which is OM, will be 3i plus j plus 2k. That is the position vector of M. Question number 10. The complex number minus 1 plus square root 7i is denoted by u. Okay, it is given that u is a root of this polynomial, given polynomial, where k is a real constant. Find the value of constant. So if a root exists for a polynomial, just substitute x by that root and you'll get a zero remainder. That's what it means. We have done this in one of the previous questions, so let's do it. So our polynomial is 2, and in place of x we will write now 1 plus square root 7i cube plus 3 minus 1 plus square root 7i square plus 14 minus 1 plus square root 7i plus k equal to 0. And when we expand these, I'm sure i's will get cancelled out. That's why we will get a value of k, because k is a real constant. I'm sure they will cancel out. So let's do it one by one. We can use our calculator to do this calculation of cube, or you can use this formula: a plus b cube equal to a cube plus b cube plus 3a square b plus 3ab square. Okay, but I'm using my calculator to get this and shorten the process. If I cube this, I get 20 minus 4 square root 7i plus 3. If I square this, I get minus 6 minus 2 square root 7 I. Then we have 14 times minus 1 plus square root 7I plus k, and that is equal to 0. Alright, so this will be how much? 40 minus 8 square root 7I minus 18 minus 6 square root 7I plus, rather not plus, minus 14 plus 14 square root 7I plus k equal to 0. And we should first look at i's because they must cancel out. 14 minus 6 minus 8, yes, they're cancelling out. Minus 6 minus 8, minus 6 minus 8, yeah, minus 14 plus 14, cancel out. 14 minus 18 is 22. 22 minus 14 is just 8. 8 plus k equal to 0, and finally it gives us k equal to minus 8. Okay, B part says find the other two roots. That's the B part. I have not copied here, but find other two roots. Of course, it's a cubic polynomial. It will have two more roots. But whenever we have one of the roots as a complex number, its conjugate will be the second root. So second root is straight away known to us. Second root will be the conjugate of minus 1 plus 7i. It will be minus 7 square root 7i. That's the second already. The challenge is to find the third root. For third root, we must convert these roots into factors first. So factors, because of this conjugate will be x minus, that's how we do it, and minus 1 minus square root 7 I. And we already had one complex number u. For that, the factor will be minus 1 plus square root 7i. So these are the two factors already. We will get the result of these two. So let's open the brackets first. X plus 1 plus square root 7i multiplied by x plus 1 minus square root 7i. So we know another identity, which is a square minus b square equal to a plus b, a minus b, right? If I consider this thing as a and this thing as b, so it becomes a plus b, a minus b, so it will be a square minus b square. So let's open this up. X square plus 2x plus 1, that is the expansion of this, minus 7 complete and minus 1, that will be the expansion of this one, which is plus 7. So what do we get? X square plus 2x plus 8. This is the multiplication of the two factors we already know, which are this and this. Okay, so why I'm doing this, let me explain to you. If I want the factors of say 30, okay, and I know that 2 and 5 are two factors, right? So what do? I multiply 2 times 5, which is 10, and divide 30 by this 10. We get the third root, third factor, which is 3, right? So that's what I did. I've multiplied these two, I got their multiplication, and now I will divide the polynomial I had with this particular result. So x square plus 2x plus 8 divides the polynomial we had, which was 2x cube plus 3x square plus 14x, and we got minus 8, k equal to minus 8. So this is what we'll do with long division now. So 2x cube and x square, I need 2x to multiply so that I get 2x cube here. Then 2x times 2x is 4x square. 8 times 2x is 16x. I subtract them, this cancels out, minus x square minus 2x, and then we have minus 8 already, and yeah, we're getting it minus x square minus 2x minus 8 when we write minus 1 in the quotient, and we are not left with anything. It is a perfect factor. So your third root, we got, this is a factor, okay? They're asking about the roots. So to convert this into root, make it equal to 0. 2x is equal to 1 and x is equal to half. This is the third root. We had second root already, this one root was given in the question, and this is the third one. Part C of the same question. On an Argon diagram, sketch the locus of a point representing the complex number z minus u equal to 2. That's what we have to show. So let me try to draw it here. Okay. Now, my scale will not be that perfect, but let's try to be as good as possible. So, we need z minus u. U was minus 1 plus square root 7 I. The locus has to be 2. That means the distance of z from this has to be perfectly 2. And when can we have perfectly 2 distance from a particular point? With a circle. So first let's focus on minus 1 plus 7i. So minus 1, suppose it is here, and square root 7 is about 2.64. So 2.64 will be somewhere here. This is the center of the circle. From this particular point, which is u, we need to have a circle with radius 2 units. So it will be something like this here, and it has to go up. Okay, let me make it a little thinner so that it is better to see. All right, this is done. On an Argon diagram, we have shown z minus u equal to 2. Okay, that's it. Now, next part says determine the greatest value of argument z. I'm talking about part D. Argument z for the point on this locus, this circle. Locus is the circle now, giving your answer in radians. So, greatest value for argument z. Just like it was z minus u basically, here it has to be z minus something, and because there is nothing here, we can write z minus 0. So 0 becomes our reference point from where we will draw the angle. So for that, let me change the color and show you that 0 origin is the working place, and this is your half line from here, and we need a greatest angle from origin with the locus, this circle. Is this the greatest? No. Bigger, bigger, even bigger, more bigger, 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 and this is the greatest when this orange line is a tangent to the circle on the left side, left lower side. This is the greatest uh, argument we can have. So to get the proper one, let's connect the center with the point where it is a tangent. We know that the tangent and radius always make a 90-degree angle. So this angle is 90-degree. Additionally, let's add this line to the center also. Okay, so now we are ready with a right angle triangle. How about this? We know this is 2 because the radius of the circle is 2, right? We can find the modulus of u. So let's find modulus of u. U is minus 1 plus square root 7. So modulus is found this way: minus 1 square plus square root 7 square, which will be how much? 1 plus 7, 8. Square root 8. This is square root 8. And now our job is this is greatest argument, and this line is giving us the greatest argument, which is this, right? In this triangle we have just formed, can I find this somehow? This one, this angle. Yes, it's a right angle triangle. I can, and then I can find the argument of u, which is this. I will add both of them, and I'll get my greatest argument of z on the locus. All right. So let's find this. Let's call this angle alpha, and we'll call this one as beta, which is the model argument of u. Alright, so first let's find alpha. In alpha we have hypotenuse and opposite, so sine we can use. Sine alpha will be opposite over hypotenuse. So alpha will be sine inverse 2 over square root 8, and it is 1 over square root 2 actually. So pi over 4. So we got alpha as pi over 4. Now we need to know beta, which is modulus, not modulus, argument of u. So argument of u, and I don't want to spoil this drawing, so I will draw it separate now as a rough drawing. So suppose this is u and this angle we want, right? But for that we can find this triangle and find this angle, right? And because we know this is pi up to this levels, we'll subtract this angle and we'll get the argument of u. So let's find this angle, because we know this is square root 7, yeah, and this is 1. The imaginary part is square root 7 and real part is 1. So we can use tan theta in this case. So let's use tan theta. Let's call this one theta. Tan theta equal to opposite over adjacent. So theta is tan inverse square root 7, which will be 1.21. Yes, 1.21. And beta, which was the argument of u, will be pi minus 1.21. We'll subtract this angle from pi, so we'll get the one we wanted. Okay, let's keep it like this. Now finally they're saying the greatest value of argument z will be greatest value of argument z on the locus will be alpha plus beta. Alpha we got as pi by 4, beta we just got pi minus 1.21, and in radians, if I put this in my calculator, I get 2.71699, which we can round off to 2.72 radians, and that's the answer.